Hello everybody, welcome to the video lecture on lists, stacks, queues, and priority queues. This is the topic of chapter number 20 of our textbook. Alright, so in this video we're going to be looking into these following objectives. We're going to explore the relationship between interfaces and classes in the Java collections framework. We're going to be looking at common methods defined in the collection interface. We're going to be looking at the iterator interface and how to traverse elements with this interface and using for each loop. We're going to be looking at ArrayList and linked list classes and the difference between them. Also, we're going to be looking at comparable and comparator interface and see the difference between these two classes. We're going to briefly look into vector ArrayList classes and differences between them and how to use this stack class for creating stacks. And lastly, we're going to be looking at the relationship among collection queue, linked list, and priority queue classes. So we are starting our journey into the data structures. Why do we need data structures? It's very important to understand why we need these data structures. Well, a data structure is a collection of data organized in some fashion. Data structure doesn't only store the data in some certain fashion, but also provides some operations for accessing and manipulating the data. So all of these data structures hold many elements in themselves, but when it comes to manipulating them, all of them are different. So we need to understand what kind of data structure is best for some certain particular task. And when we understand what kind of data structure we need in some certain situation, we're going to be able to build more, perform like more efficient software, more efficient programs. So Java provides these classes called, so you can see these classes in this diagram here. This is the relationship of classes in Java collections framework. So on the left side we can see interfaces: collection, set, list, queue, deck, sorted set, navigable set. In the middle we can see abstract classes. These abstract classes are also called convenience abstract classes because they provide partial implementation for the interfaces. And on the right side we can see concrete classes. These are the classes we can use. These are already, concrete classes, we can use them in our programs. So this is the relationship in the Java collections framework. Now, these classes are not the only classes in Java collections framework. Java collections framework also contains maps. We're going to be studying maps in our next video lecture. So let's first look at the concrete classes and what these classes are. So we can see that some of the classes are sets: tree set, hash set, and linked hash set. Set is a data structure that contains non-duplicate elements or unique elements. The elements in this data structure do not repeat. Okay, they are unique. And then we have array list, linked list, vector, stacked, hash, priority queue. The elements in these data structures can repeat. They can contain repeating elements, and it like preserves the order in which you insert the elements into these containers. Yeah, we also call these data structures containers because they contain the collection of some elements, the group of elements. The sets do not preserve the order. When you add the elements into this set, you're not guaranteed that the order is preserved. The difference between the list, stacks, queues, and priority queues is this. So the list classes are ArrayList and linked list. Basically, they just store the ordered collection of elements and they provide you the methods. Also, vector is considered as a list because it's very similar to ArrayList. Stacks are kind of like lists, but they have some certain methods that allow you to process the data in some certain fashion. So these the stacks use the last in first out kind of way of storing and accessing data. So the first element you put into the stack is going to be the last element you take out of the stack. It's like a box containing books. Okay, when you put your books into the box, the last book you put is going to be on top of this box, so it's going to be the first element you take, and the first element you put into the box is going to be the last element you take. Queues are, so in this diagram we can see that there are no queues, but we can use linked list to simulate queues. We don't have a separate concrete class for queues, but we can use linked list as queues. We're going to be looking at later in a moment. So the queues are also they're like stacks, but they have these first in first out order. The first element you put into the queue is going to be the first element that you take out of the queue. It's just like the queue at the dining hall. Yeah, the first student that takes the meal is going to be the first student who pays for the meal and who's going to start the meal first. And the last data structure is priority queue. Priority queue is a queue where the order in the queue is dependent on the priority. So for example, it can be, let's say, when you're in a bank and there are some people who participated in Second World War, yeah, they are going to be served without the queue, right? So they come, and whenever they come, he's going to be or she's going to be the first person who's going to be served by the bank manager. All right. So now let's look at some of the common methods in the collection interface, and then look at the code. So this UML diagram here shows the list of methods in collection interface. The collection interface is the father of all, is the root class for all collection classes. All of the collection classes have this method. So these methods are like very basic for all the collections. First, add all. These two methods add elements into the collection. In add all, we can see collection question mark extends E. This question mark extends E means that into some collection that contains the elements of type E, you can add any collection that contains elements of type E or subclasses of E. Okay, question mark means any class. We have a method called clear that removes all the elements, contains all, checks whether some certain element or elements contain in this collection, equals checks if one collection is equal to the other. Hash code, we don't need this for now, is empty, returns if this collection is empty. Remove all, removes elements from the collection. Retain all, keeps elements in this collection that are also in collection C. Okay, it's like intersection. Size returns the number of elements, and toArray gives returns the array version of this collection. Array, you know, it's a fixed size container. Also, the collection interface is like sub-interface of the iterable interface. Since in a collection we can have lots of elements, we need to be able to traverse them using a for loop, right? So we don't use collections just to store elements, we also use collections to process elements. So that's why we need to be able to use a for loop to take all the elements of any collection one by one. So collection inherits this, collection interface inherits this iterable interface, which has a single method called iterator. Iterator is a special object. You can think of iterator as as an object that can control, that can traverse or iterate the collection, very simply. It's like an arrow, yeah. This element, next element, next element, and so on and so forth. So this iterator method in the iterable interface returns an iterator instance of iterator, and iterator itself is actually an interface which contains three methods called hasNext, next, and remove. HasNext gives true or false depending whether you are at the end of the collection or not. You can put this hasNext into a while loop, and then it's like scanners hasNext, yeah. And then we have the next method, which gives whatever the next element is. Its return type is E. So if your collection contains strings, its return type is going to be string as well. Remove removes the last element obtained using the next method. So if you call remove before calling next, it's going to be an exception. There is going to be an exception. You always call remove after you call next, and you can't call remove on an empty collection because there are no elements to remove. Alright, now let's look at some of the methods in the collection interface. So this is the code. So here we are creating a collection. Collection 1. We know that ArrayList is a concrete subclass of the collection interface. It's like very basic collection without any superpowers. Okay, you can add elements, remove elements. It's very dynamic, and internally it just uses a simple array to store the elements. So here we're adding some of the cities: Almaty, Shymkent, Bishkek, Kızılorda, and then we're printing the elements in this collection. So ArrayList implements the string method, that's why we can see its contents easily. And then we can check using the contains method whether some element exists in this collection or not. We can remove elements by their value, and then we can get the number of elements in this collection, size. This is also a method from the collection interface. And then we're printing it after removing Bishkek. And we're creating collection number 2. It contains some of the other cities, but it contains like Almaty as well. So both of the collections contain Almaty. We're printing the cities in collection 2, and then we're cloning collection number 1. Okay, we're making a copy of this. Clone makes a copy, and it returns an object. That's why we need to cast it into an array list of strings so that we can store it in an array list of strings. And then we have the add-all method. It's a method also. This method is also in collection interface, which adds all the elements of collection 2 into this cloned collection. Basically, it adds all the elements from this collection to this collection, and it doesn't add the repeating element. For example, it adds Astana, it adds Moscow, it adds Boston, but it doesn't add Almaty because Almaty is already here. It's very similar to union operation in sets. In Venn diagram, you know, when you draw these two circles, the union is going to be the shaded area of both circles. Then we print this cloned collection. Then we clone again. Okay, so clone collection is going to contain these 4 cities right away. Retain all is like intersection. It means keep all elements in this collection which are also in the second collection. So Almaty is in the second collection, so we keep it. Shymkent is not here, we remove it. Bishkek is not here, remove it. Kızılorda is not here, remove it. So we have only Almaty here. And the last method is remove all. It just means remove all elements from clone collection that are in collection number 2. Almaty is here, yes, remove it. Shymkent is here, no, keep it. Bishkek, it's actually already removed. Kızılorda is here, no, keep it, okay? And remove all elements that are in the collection number 2. So let's run this code. Alright, so this is the result of our program. The list of cities in collection 1, these are 4 cities. Is Almaty in collection 1? Yes, it's there. Then we remove Bishkek, and 3 cities are going to be left in the collection number 1. In collection 2 we have Astana, Moscow, Boston, Almaty. The cities in both collections, this is the union. You can see that, oh, you can see that the Almaty actually is there, so it actually doesn't, it actually adds the duplicating elements. I'm sorry for the mistake. And we have the next one, collection 1 and collection 2. This is the intersection of these two collections, and then cities in collection 1 but not in 2, Shymkent and Kızılorda. This is the last method call. Alright, now let's look at iterators. Iterators are not as bad or as scary as they sound. They're actually very simple. So we know that iterators have only 3 methods: has, next, and remove. So we're going to be looking at all these 3 methods one by one. First of all, let's do the has, next. First of all, we need to create an iterator. Since our collection contains strings, it's made of, it contains strings, so our iterator should be string. Iterator string. I also forgot to import. And yeah, it's an interface. We can't write new iterator. We need to use the method of the collection in order to get it. We write collection.iterator. Okay, now we have this object. Let's just click and see what kind of methods it has. Has, next, and remove. Also, it has for each remaining, which you can use with lambda expressions, but we're not gonna look into this in this video. You can do it at home if you want. Let's start with the has, next one. So it returns a boolean system.println has either has, next. Let's run it. So initially the iterator is going to be in the beginning of the collection. It's like it still has 4 elements to traverse. That's why the has, next should return true. We can see that it returns true. Now let's write a loop using this has, next and print all the elements in this collection. So while iter.has, next, what do? We need to get the next element, right? So it can't, if we don't move this iterator in this loop, it's going to be forever in the first initial position, and this loop is going to be an infinite loop. That's why we need to move this iterator so it reaches the end of the collection. So in order to move it, we use the next method. Also, this next method returns the elements. So first it returns Almaty, then Shymkent, then Bishkek, then Kızılorda. Then it doesn't have any next element, it just stops, okay? So we just get string city equals iter.next, and then we just display, let's make all the letters uppercase, like this. Alright, let's run this. And this is the result of our program. We can see the list, all the cities are printed. Now, how do we remove using iterator? How do we remove elements using iterator? Let's comment this code here. Let's try to remove element before adding some elements into this collection. Sorry, I was trying to do, we need an iterator, and then we do iter.remove. And let's make so that our collection is empty. And we can see that we get an illegal state exception. That's because the remove method removes the last element that was returned using the next method. Even if we add 4 elements into this collection and then try to remove using the iterator is like before Almaty, right? So it's just at the beginning, and it doesn't, the next method was not called, and when we run such code we're going to see illegal state exception because we didn't call the next method. That's why in order to remove, for example, Shymkent with iterator, we need to move the iterator twice. Almaty. So it's now pointing to Almaty. Now we go to next one. It's gonna point to Shymkent and return Almaty. We do next. It's gonna point to Bishkek and point to Shymkent. The Shymkent was the previous element that we got using the next method, and when we call remove, it's going to remove the element that previously was returned using the next. So in order to remove Shymkent, we need to call iter.next twice, and in order to see the contents of this collection, let's actually print it using just system.println. And indeed we can see that Shymkent is removed. One of the important things about the iterator is that you can move the iterator only forward. You can't move it backward. So when you have one loop, so let me actually remove this part of code. When you have one code that iterates over the collection, and then you write the same code using the same iterator, this iterator in this loop is going to reach the end, and next time it's not going to enter this loop. Why? Because it already reached the end. So you can't move it to the beginning of the collection. In order to be able to move it to the beginning of the collection, we need to call this method once again. So let's try this code now. We can see that the cities are printed only once. Now let's try with this before running this loop. And now we can see that our cities are printed twice. So in order to do the iteration from the beginning again, we need to call this iterator method once more. Okay, so that's it for the iterators. Now let's look into the for each loop. So we know this for each loop from our from the beginning of the semester. We used it in several places, yeah. So we can use it for arrays, we can use it for array lists, and we can use for each loop for any collection. So for each loop is written like this: for each string city in collection, what do we do with this city? We just do system.println city.toUpperCase. Let's run it. And we can see that the cities are indeed printed. So this for each loop works exactly like this one. So in the background, what's happening is this for loop just takes the iterator of this collection and then uses this iterator to iterate over this collection. So basically this for loop is actually has this mechanism, has this loop inside. Okay, you can think of this as this. So when you need more control over what you want to do with the data, like removing some of the elements, you can use this iterator, and when you just simply need to iterate over the elements in the collection, this method is going to save your time because you're going to write less code. Alright, let's continue. Now let's talk about lists. A list is an interface that extends the collection interface, and it defines a collection for storing elements in a sequential order. Some of the classes that implement two of the classes that implement the list interface are ArrayList and LinkedList. So ArrayList and LinkedList both have the same common methods you can see in this UML diagram. So the list interface has the add method. You can add an element into a certain position in the array list or a linked list, and also you can add all the elements in some other collection to some certain position. It returns a boolean. Probably it returns true if the addition was successful. We need to check this in the documentation. So it has the next method get, which gives the element at some certain index. You can check the index of some certain element. So get and index of are kind of like a verse of each other, or complement each other. Last index of gives you the index by looking from the right side. Index of looks from the left side, and last index of looks from the right side. List iterator is a subinterface of the iterator interface. It's a method. List iterator is a method that gives a list iterator. And also you can get a list iterator starting from some other index. We're going to look at list iterator shortly. Remove is a method that removes some certain element at some certain position, and set is a method that changes an element at some certain index. And sublist returns a list containing the same type of elements between these two indices. The from index is included and to index is not included, as you can see in the description of the method. Now let's look at the iterator, list iterator interface. So list iterator is the subinterface of iterator, and it has some additional methods like add. It adds the specified element into the list. Has previous tells you whether there is a previous element. Next index gives you the index of the next element. Previous gives you the previous element. Previous index gives you the previous index, and set replaces the last element returned by the previous or next method with the specified element. So here we don't have the next method. Actually, it's in the iterator interface, which is the super interface of list iterator. Also, we don't have remove, which is also in the iterator interface, and has next is also in the iterator interface. So this list iterator has some additional methods. Now let's talk about the ArrayList and LinkedList classes and their differences. As you can see in this image, both of the we can see like the data, 5 numbers, 23, 3, 17, 9, and 42. Both of them are stored in sequential order. In the upper part, we can see that the elements are indexed. This is how ArrayList looks like. So all the elements in an ArrayList have indices. ArrayList internally uses simple arrays. We actually implemented array lists in one of our previous lectures. ArrayList is simply a dynamic array. Initially it contains the fixed size of elements, and when this array gets full, you like double this container, double this array in size, and then add more elements. Each time you need more space, you just double the initial internal container. And linked lists, as you can see from these arrows you can think of them as links. Link is something that connects two elements. So we can see a link that goes to the right and link that goes to the left. So the one that goes to the right is actually a reference to the next element. Yeah, you can call this next, and arrow to the left is actually like previous, previous element. So each element in this linked list only knows what is the element on the right side and on the left side, or what's the next element, or what's the previous element. So these two data structures, ArrayList and LinkedList, store the same data, but in different ways, right? And they have, when it comes to doing some certain operations, they both behave differently. So some of the operations you can do with ArrayLists and LinkedLists. We're gonna be looking at each of them one by one. When you get an element from an ArrayList, since all the elements are indexed, it takes constant time, right? So you can get any element from an ArrayList using constant time. in constant time. But in linked list, since you don't know the index of the element, you need to go up until that element by using that links. So if the element, you want to get the 0th element, it's going to take one operation, but if you want to get the last element, it's going to take n operations. So the complexity of getting the element at some certain index is O of n for a linked list. So getting element at some certain position is more efficient in array lists. And when it comes to adding elements into array lists and linked lists, adding element to the end of the array list is it takes constant time, because you just add it into the array. But adding an element into the beginning of the array list takes linear time. Why? Because you need to shift all the elements in all the existing elements in the array list by one position to the right, and then you put your element into 0th position. So this adding elements into an array list to some certain index takes linear time. But when you want to add elements into the linked list, and if you want to add it into someplace in the middle, it's going to take on average n over 2 time, n over 2, because you can go either from the left side or from the right side, and the furthest you go is going to be the half. So on average is going to be n over 2. If you want to add elements into beginning or end of the linked list, it's going to take constant time. So when you, in your program, you do lots of insertions into beginning or ending of the list, it's more efficient to use linked list. When it comes to removing elements from array list or linked list, it also depends from the index. Removing the 0th element in an array list means you need to shift all the elements by one position to the left, and removing the last element in the array list is constant. Removing first and last elements in the linked list it takes constant time operation. That's why removing and adding are both more efficient in linked list when you do it at the beginning or the end of the lists. So considering these cases, you choose the data structure that is more suitable for you. So when you need to support random access through an index without inserting or removing elements at the beginning of the list, so array list is going to be most efficient. But if in your application you need to insert or delete elements at the beginning or at the end of the list, it's better to use linked list. Now let's look at the code where we may programmatically check the difference between adding and removing elements to the beginning and to the end of the array list and linked list, and also accessing random elements at random indices in both array list and linked list. Let's see the difference. So before we see the difference, let's first analyze the code. So we have these two variables, start and end, which we're going to use just to mark the time. We're going to mark the time with system current time millis. It returns a number of milliseconds from some certain time, yeah. And then we do some operation, and then we mark the time again. And the difference between these two variables is going to be the amount of time it took to do this operation in milliseconds. That's the logic which we're going to use. This n here denotes the number of iterations that's going to happen. And we have two lists. First is array list, and then we have linked list of integers. We're going to store integers there. All right, so the first code here is going to check how long does it take to add elements to the end of the lists, to the end of the array list and linked list. So we mark the time, start and end, and then we write a loop that repeats n times, and then we add elements to the array list. Add element by default is going to add the elements to the end of the array list. And then we're going to print array list, add n elements to the end, and how many milliseconds it took. The same we do with the linked list, but in linked list we don't use the add method, we use add last to add the elements to the end of the linked list. Then we have part of the code that's going to do add first. So again, we mark the time, and to add an element to the beginning of the array list, we use the add method where we specify the index. So in this case, we always add to the 0th position. It's going to add to the first element. And in the linked list, we're going to call the method add first. Alright, so now remember, when we add the elements to the end of the array list, we just append it. I mean, we just add it, and if we need more space, we're going to double the size of the array list. If we add the elements to the end of the linked list, we just create one node and the links between them. So it's like constant time operation, but sometimes for array list, it's going to take some time to actually grow the array inside that array list. So in both cases, they're going to be roughly the same. But when we do the add first one, when we add the elements to the beginning of the array list, we have to shift all n elements by one position to the right. But in linked list, we just need to put a node and then just establish the links between them. That's why for the linked list, it's going to take constant time, but for array list, it's going to take a linear time. So when we repeat loop n times, it's going to be like add itself is a linear, this is also linear, it's going to be quadratic time. So adding first to the beginning of the array list is very, very inefficient when with respect to the linked list. So when we will see here, we hope to see that linked list is going to behave more efficiently in this part. Now we're going to do remove first. Remove first, when we do it with array list, we just remove the element at some certain index, remove 0, but for a linked list, we just call the method called remove first. Again, when we remove first element from the array list, we need to shift all the remaining elements by one position to the left, because the first spot in the array is empty, so that's why we shift the elements. And when we remove first in linked list, we just need to break the links between the first and second elements and make the first element as the head of the linked list. I mean, the second element as the head of the linked list. That's it. So this is kind of like constant time operation. So for linked list, removing first element is very efficient, but for array list, it's very inefficient. Remove last. In both cases, for both array list and linked list, they should be roughly the same, because for array list, there's no shifting happening. So it's like constant time operation, and for a linked list, we just need to remove the links between the last element and the previous to last element. And lastly, we're going to do random index access. In this case, so first we fill the elements because we have emptied our both of our lists. We fill them with numbers, and then we're gonna, so they're gonna contain n numbers, and then we have a loop that repeats n times. And in this loop, what we're gonna do for array list, we're gonna get some random index. So get is a method that gives, this is actually a method from the list interface that gives you the value of the element at ith position. So here to make it fair, we're gonna access at random positions. So here we generate a random number between 0 and 1. We multiply it by the size of the array. It's going to be between 0 and n. But since this is double, we need to convert it into an integer. And then we just store it into some variable j. The same we do with the linked list. We just it's like since this is the common method, there is no change except these variable reference parts. So here, since linked lists and array lists use different way to store the elements, array list is going to perform much better because it has indices for each element. But in linked list, in order to get to the ith element, we need to have a loop I times, right? Because we're going to start either from the beginning or from the end, and we need to travel to the ith position. And it's going to take I steps. in the worst case, it's gonna probably be n over 2, because you can go either, I mean, the furthest from both ends, you can go from both ends, yeah, and the furthest you can go is right in the middle of the linked list. That's why it's gonna be on average n over 2, and linked list should perform poorly here. So let's run this program and see the results. Alright, we already can see the results for adding elements to the end. Both of them are roughly the same. These numbers are going to be different each time, because operating system is going to allocate the resources differently at each moment in time. Adding elements to the beginning is much bigger for array list, like 16 seconds against 125 milliseconds. Removing from the beginning is also, look, is very big number for array lists. And removing from the end is roughly the same. And random access of elements is 97 milliseconds for array list, and for linked list we are still waiting. Imagine writing a program where you randomly access elements and you use linked list. Your program is going to be very slow and inefficient. 32 seconds. It's a very inefficient way to access elements at random positions. All right, I hope this example gave you clear understanding clear understanding of the difference between array list and linked list when it comes to adding and removing elements from the beginning and to the end, and randomly accessing elements at some certain positions. Let's talk about comparators. If you look at this image, you can see lots of kids standing up, and a teacher on the right side looking at them, right? So this is a physical education lesson at a normal school, at an ordinary school. So usually in this kind of lessons, students line up by their height, right? So the shortest student is going to be on the right side, and the tallest student is going to be on the left side, and all of them are going to be sorted by their height. So assume that the kids are very, I mean, they are studying in 11th grade or 10th grade. They're already like adults, yeah, maybe teens. And when teacher tells them to line up by their height, what's going to happen? They're going to look at each other and they're going to compare each other's heights, and then become sorted. So if you see that on your left side there is a taller person, you're going to swap with that person. And each student is going to just repeat this step, right? So if a student sees on the left side a taller student, they're going to swap. If a student sees a shorter student on the right side, they're going to swap. And this way, using the simple algorithm, they're going to be able to line up by their heights. And now, so this situation is when these students know how to compare each other to each other. So each student knows how to compare himself or herself to other student. So this is an example of comparable interface, because comparable is ability of an instance of a class to be able to compare itself to an instance of the same class, usually the same class, to be able to compare itself, right? Now let me give an example of comparator. Assume that the same teacher, but the different students. This time it's like the first day of first year kids, okay? They are like 6 or 7 years old and they don't know anything, and this is their first physical education class. And instead of, for example, teacher to explain them, I'm actually giving an example which probably might not work in real world, but just assume that the kids don't know they're very small, or maybe kindergarten, okay? They don't know how to like compare each other's heights themselves. So what does teacher do? Teacher looks at two students, and then if a student on the left side is shorter than students on the right side, the teacher is going to swap them, okay? So in this case, teacher is going to be the person who decides which student is bigger, or, which kid is taller or shorter. This is an example of comparator. Comparator is an external object which is able to compare some other objects of some type, okay? So I hope now this makes sense to you. Now let's look at the code. Now this is an example of a code where I use comparators. So basically, I have a list of strings. So I created a list of strings, it's called cities, and it's going to be linked list. So you can use this. So this is like the super type of the linked list. That's why you can store a linked list in that. No problem here. But this cities is going to be internally is going to be using a linked list. Okay, so if you as we previously discussed, if you try to access at random indices in the cities, it's going to be very, slower than if you used array list. But for small lists like that contain only 7 elements, there's not much difference. So yeah, let's just use linked list here. So we added like 7 cities in Kazakhstan. I'm not sure about Terekti, but it might not be a big city, but certainly I've heard somewhere that we have some place like this. And then we print the unsorted, initial this list in initial order. So you know that linked list, it stores the elements in sequential order. That's why when you add Taraz before Shymkent, it's always going to appear before Shymkent, for example. The order of the elements is going to be in the same order as you add the elements. That's why when we see the cities, at this point we're going to see in the same order. Taraz, Shymkent, Terekti, Kızılorda, Astana, Oral, and Taldyqorghan. And then what if we want to sort this list in some different ways? For example, we can sort these strings by their length. Oral contains 4 letters, Taraz contains 5 letters, right? Astana contains 6 letters. So why don't we compare by the number of letters in a string? So if we compare alphabetically, of course Astana is going to be first. Astana is going to be first. This is like the natural ordering of strings. Natural ordering means how do you compare some certain elements naturally. So that usually comes with the comparable interface. So strings already implement the comparable interface, and naturally they are sorted by alphabetically. And if we want, we can also sort strings in some different ways. That was what I was going to tell you. So we can sort them by length. So how do you sort them by length? You can write a sorting algorithm from scratch, but that's not the best solution, because each time you will need to sort this, you will need to write a separate method, or you will need to write the algorithm again and again, instead of using an existing sort method in the collections class. We're going to talk about the sort method shortly. Alright, so how to sort these elements by the number of letters in them? In this case, we're going to use comparator. Comparator is going to be an external object which is going to be able to sort 2 elements by their length, and that's what's going to happen here. So comparator is an interface, and we need a class that implements this interface, and this class is going to have to implement one abstract method in this interface, which is compare. So compare takes 2 strings, right, and then compares them. If O1, object 1, is bigger than object 2, in this case we compare their lengths, then we return positive number. We can return 1 in this case. If the length of the first object is less than the length of the second object, the second string, we return -1. And if both of the cases are false, it means they're equal length, and we just return 0 because we consider them equal if they contain the same number of letters. And then how do we sort them? The collections class has a wonderful method called sort, which accepts a list and then a comparator. We just send an instance of this comparator into that sort method, and that list is going to be sorted by length. After that, we can also sort these lists in some other different ways. Just try to fantasize and see if you can make up some order. So I came up with sorting alphabetically but in reverse order. For example, we're going to look at the last letter first. Yeah. For example, A is the first one, and then if they're same, we're going to look at N and D. So in this case, Kızıldağ is going to be smaller than Astana. Alphabetically, we're going to look from the right to left of the word. Okay, so alphabetic from the end of the word. And I call this comparator reverse alphabetic comparator. So how does this reverse alphabetic comparator work? So this comparator is going to take two strings and then reverse them. So we can reverse strings using the string builder classes method called reverse. We convert both of the strings into string builders and then call this method and then make these strings again. O1 and O2 are going to be like the reverse strings, and then we compare both of these strings using compare to ignore case. This is actually a method of the string class, and we don't have to write alphabetic ordering in this case. We just can call that method, and then we pass that reverse alphabetic comparator into the sort method. Let's see the result of this program. Yeah, this is the result. So this is our initial ordering. Taraz, Shymkent, Terek, Kızıldağ, Oral, Taldyqorghan. Sorted by length. You can see all of the cities have a different number of letters on purpose. 4, 5, 6, 7, 8, 9, and 11. And here we sort them alphabetically from the end of the word. This is ad, rol, right? Which is less than ana, which is less than itk, which is L, N, T, Z. Okay, so this is sorted that way. So using this logic, you can create as many comparators as you want, and you can sort your list in many different ways you want. Everything just depends on your imagination and your needs. Now let's talk about vectors. Vectors are very similar to array lists, and both of them have had different methods initially, but in Java version number 2, developers introduced Java Collections Framework and like joined vector and array list into one framework, right? Which we saw at the beginning of this video lecture. So what is similar between array list and vector? Well, they're similar because they store the elements in the same fashion. They store the elements in an array internally, and if this array gets full, they like grow it by some factor, and so on and so forth. Both of them have the same complexity for different operations. The difference comes in that vectors methods are synchronized. So we're going to talk about synchronization in our later videos. Synchronization allows multiple threads accessing the one vector to not corrupt or to not change the data in the vector in a way that you don't want. Okay, so vectors are safe when it comes to multi-threading, but array lists are not synchronized. That's why they are not safe. The data in array list can be corrupted when you use it in a multi-threaded program and multiple threads access your array list. So this is the only difference between vectors and array lists. In most of the cases when you write non-multi-threaded programs, you're going to use array lists because they're going to be a little bit faster because they are not synchronized. Synchronization takes a little bit of overhead. If we look at the methods of the vector, well, all of them can be understood by their names, but since a vector was not initially in the Java collections framework, some of the methods in vector class are different than the methods in the collections framework. For example, add element. This method is not in the collections framework. In collections framework, its name is add. Add element was vector's initial method name. This is one of the examples. Alright, now it's time to talk about stacks. So stacks are in Java util package, as you can see here. I'm gonna just give an example of using stacks. So assume that you are moving from your dormitory to your house due to this coronavirus. So you need to take all of your books and put them into a box, and then take them with you to your house, to your home, and then take out the books from the box and then put them into the shelf. Okay, so what's the algorithm? Put the books from the shelf in your room, in dormitory. Put the books into the box one by one and take them home. Take out the books from the box one by one and put the books to your shelf at home one by one. Okay, so this is the algorithm. So the constraint is that the size of the box is equal to the size of the book. Or I mean, you can't put two books on, the books should be on top of each other. Okay, the books should be on top of each other. So this is gonna be, the box is gonna be like stack. Okay, because you can put the books only from top, and you can take the books only from top. So if the book is at the bottom of the box, you need to take out all of the books in order to get it. Alright, so let's say that the shelf is gonna be some list of strings, shelf equals new, let's say it's gonna be array list. And then on the shelf we have the book calculus, okay, and then we have linear algebra, then we have differential equations, and then we have programming. 4 books on your shelf. We're gonna write a loop. Actually, let's write an indexless for each loop. For each string book on your shelf, what you do with this book? You put it into the box, right? My books that push. You push the book into the stack. Then you do transfer, and then let's actually system.println here, putting book into the box. Okay, then system.println going home. Then we have the same loop, and this time it's gonna be while stack my books dot size is bigger than 0. What do we do? In other way, this is gonna sound like while my box is not empty. Yeah? We're gonna take out the book. Take out. Now we need to see what's the topmost book, right? So we're gonna say my books.peak. This is gonna it's just like looking, okay, without taking it out. And then what do we do in real life? What we do my books dot pop. Okay, pop, it just removes. Actually, we could write here pop. It would print and remove at the same time, but there is actually no difference here. And at the end, we just write done book transfer. Let's run this program. All right, so here you can see putting calculus into the box. It's going to be the first book, then linear algebra, then differential equations and programming. Then you go home. Then you take out the books, right? Pop and or pick, doesn't matter. Taking out programming is going to be the first one, and then you take out differential equations, and then you take out linear algebra, and then you take out calculus, and then it's done. Okay. All right. I hope this example made it clear on how stacks work. Now let's talk about queues, decks, and linked lists, and like a relationship between them. Queue is a data structure with first in, first out principle. So the first element you put into the queue is going to be the first element you take out of the queue. It's just like the same example as I gave you at the beginning of this video lecture about the line at the dining hall at lunch, for example. So what are some of the methods in queue? So offer is a method that puts an element into the queue. Poll retrieves, gives you the element and removes it, the head of the queue. The head of the queue is going to be the first element that's going to be out. So if the queue is empty, it's going to return null. Remove removes the head, returns it, and throws an exception if the queue is empty. So poll and remove are different only in when it comes to throwing exceptions or returning null when the queue is empty. Pick and element are both kind of like the same. They don't remove the element, they both retrieve, but pick returns null if the queue is empty, and element throws an exception if the queue is empty. So since this class is very simple, I thought about not giving you an example for this particular class. Just let me know if you need help with this queue class. So next class is deck. Deck sounds like something scary, but it's not scary. Deck is a double-ended queue. A double-ended queue means you can put elements and take elements from the beginning and end of the queue. It's like from both sides. So it's very similar to the queue, but queue only takes elements from the head, but the double-ended queue can take elements from both sides. There are no classes, concrete classes for queue and deck. If you look at the class relationship diagram of the Java Collections framework, you can see that there are no concrete classes for queue and deck. Why? That's because the linked list class actually already has the capability to simulate the queue or double-ended queue. Linked list has methods like adding elements to the beginning and removing elements from the beginning, adding elements to the end and removing elements to the end, from the end, and these four methods are enough to simulate a queue. So in fact, the queue is an interface, and linked list class implements this interface. It means it already has the offer method, poll method, remove, pick, and element methods. Deck is also an interface which has these methods called add first, remove first, add last, remove last, get first, get last, which linked list implements. So you can use linked list class in order to simulate these the queues. All right, now let's talk about priority queues. This is the last thing for today's video lecture. So here we have, I'm going to create a class person, and then we're going to be working with this person class to understand priority queues. So priority queues, as I told you guys earlier, is a class where the elements are located in a queue, but they are not served in first come, first served basis. So assuming that you are sitting in a bank office and you are waiting for your line to come, and at some point there's some veteran that participated in Second World War comes in. These people in Kazakhstan are served without waiting on any line. When this person comes, this veteran, old person, this person is going to be he's not going to wait in the line, so he's going to have more priority. So we're going to simulate this. So first of all, we're going to finish writing this person class. So we have a person has a name and an age. Let's include a constructor for both of the data fields. And let's include getters and setters for both of the data fields. And then let's include the toString method that is going to print the contents of this object by showing its name and age. So person class is ready. Now let's create several people. So we're going to create person. Alright, so these people are going to be served by their ages. So this is a special bank where older people are served first. We're going to make these people's ages different. Let's say Rahmjan is an old person, 80, and Aliya is also an old lady, 70 years old. Quat is very young, he is like, I don't know, 18 years old. And Slushash is, let's say, 40 years old. Alright, so these are 4 people. Now we're going to add them into the priority queue. We're going to create a priority queue that contains all these people. This is going to be queue equals new priority queue. So if we look at the constructor here, we can see that we can create these priority queues in many different ways. We use the first constructor where the elements are ordered using their natural ordering. Natural ordering means that they are required to implement the comparable interface. We also can create these priority queues by using comparators. So this comparator is going to be used in order to distinguish which of the elements in this queue should be served before, right? So let's try to add some elements into this queue. Offer P1, P2, P3, P4, and P5. All 5 people, and this time we are using the natural ordering. Now let's try to print the contents of this queue. And then here we're going to be serving. While this queue is empty, is not empty, what we're going to do? So we need to remove the element from this queue and print it. Let's see the result. So this is the result of our program. We have a class cast exception happening. So it's saying that we can't cast a person to comparable, right? So the natural ordering of the elements assumes that the class implements the comparable interface, but our person class doesn't implement the comparable interface. So we can implement the comparable interface in which we compare people by their ages, right? But I don't think this is the natural way to do it, because person. Why do we need to implement the comparable interface only for the queue here, right? So if we create some other queue where the priority is in different order, so are we going to change the comparable? Probably not. That's when we are going to create the comparator interface, the instance of the comparator interface. So now let's create this queue by using the comparator interface. We're going to say new comparator person. It's going to be anonymous interface. Let's try to do it. So we need to now implement the compare method in this anonymous interface. How do we compare two people? So we need to compare them by their ages. Alright, so this is the result. Here the serving order is in a reverse order, right? So it actually takes out the smallest element in the queue. So I forgot about that, so we need to change it. So if the person first age is bigger than the second age, in this case it has the lower priority. Here it has the higher priority. Now let's run again. So this is the result. So the smallest element is going to be served first. The smallest element in that was found by using this comparator. So the smallest one should be the one with the greatest age. So 80, 70, 40, 20, and 18. This is the order of people that are served. So I hope this example gave you a clear understanding of priority queues. Now let's wrap it up. I hope you learned something in this video lecture. Today we talked about lists, stacks, queues, and priority queues. We explored the relationship between interfaces and classes. What is the Java Collections framework? We tried to understand it. We looked at some of the basic and common methods of collection interface. We also looked at what iterator is and how to traverse elements using iterator, and how to use for each loop in an iterator. How to use for each loop for a list. We looked at the differences between ArrayList and linked list classes. We looked at differences between comparable and comparator interface, and we wrote a really fun example where we compared strings. Then we looked at vectors, ArrayLists, and stacks. Then we talked about queues, decks, and linked lists, and we wrote one example using priority queue. Now, the homework for this video lecture is this. So you will need to make a video where you explain some of the concepts in this chapter. The requirements for the video are this. The minimum duration for the video should be 5 minutes. So you can create a video at least 5 minutes, but let's say no longer than 10 minutes as well. Between 5 and 10 minutes. Also, you will need to show your face. I want to see your face, so I can see you talking in the video, just like me in the lower right part of the video. Also, make sure that you use proper place to record your video, so your voice can be heard easily. So what you need to explain. So this chapter contains 2, 3, 4, 5, 6, 7, 8, and 9. These are the sub-chapters in this big chapter. So the numbers are 2, 3, 4, 5, 6, 7, 8, and 9. You will need to find your ID modulus 8 plus 2. And the number you get is going to be the sub-chapter you will need to explain. I'm going to give an activity point for the homework and for the attendance. But if you find this homework to be very difficult, I can just give you a point for the attendance in Portal. So in this case, if you want to get your attendance point, you just need to send me an email where you say, I just want to get an attendance point. And after you send me your homeworks, your videos, I'm gonna upload them to my YouTube channel where you can see other students' homeworks as well. Thank you very much for your attention. See you guys in the next video.